Okay, I think we're on. Okay, everyone, welcome to the Node Lifecycle Working Group weekly meeting. Today is Monday, the 6th of October 2025. I'm Lucy. I'm one of the leads of the Node Lifecycle Working Group. As a reminder, although I'm sure none of you need the reminder, this meeting is being recorded and is governed by the Code of Conduct. So please do not do anything stupid. With that, I'd like to start by bringing back the agenda item that kept getting ignored. I'm going to revive it, which is welcoming new attendees, if any, and intros from new attendees if they wish. So if you're new to this working group, if you want to introduce yourself, maybe talk about why you've decided to come here this morning, afternoon, evening, then please go ahead now.
Okay, so let me start. My name is Jens. I'm from AWS. I'm just in vacation, so I'm joining from my mobile phone and from my private email account. So I'm in a customer-facing role in the support organization. So I'm not from the support team, and I'm not from the service team, which do our EKS, our Elastic Kubernetes services stuff. But I'm in the role between, like a glue or a bridge between customers and our support and service team folks. And I brought up this issue, which I put into the agenda, and that's why I'm here today. And I already talked with Jonathan, who joined this calls earlier, a couple of meetings ago. So that's why I'm here. Thank you for having me.
Absolutely, welcome. All right. Anyone else would like to introduce themselves? Not very good at counting down with my fingers. Okay, then we will move on to the next thing on the agenda, which is Ryan with Specialized Lifecycle Management. Ryan, do you want to take this? I assume this is you. It doesn't have a name next to it, but
Yes. Oh yeah, it is me. So, well, I was gonna ask though before we go with this because I mean I can talk about. I mean I doubt we'll even get through. Well, maybe we'll. I don't know. We'll probably spend a bunch of time on this. So I wanted to ask if we should start with the second topic first, and go through that.
yeah, I think that's fine. I don't know how much time you wanted, but yeah, if let's just do that then. So Jens, you're back on already. Coming
Okay.
on to your topic, two interesting issues in Implement FastPath. I'll let you go ahead and let me know if you need
Okay.
screen share.
Cool. Yeah, thank you. So initially, I raised this topic in the Carpenter AWS provider repo, but it's closely related to node lifecycle, especially to node termination. And this is based on customer experience. So in my role as a container specialist at AWS, I brought this two customer topics into this issue. The first one was one where a large customer which runs huge AI ML workloads, they just called me one day and told me we have lots of unreachable nodes, a couple of hundred unreachable nodes, and they want to know why this happens because they are pretty sure that they don't put the nodes under node pressure so that kubelet is not responding anymore, things like that. So I have access to internal toolings like the audit logs of this customer. And what I see is that this issue happens when Carpenter tears down or scales in the nodes. So it was surprising already that this happens when Carpenter scales in and terminates loads because the workload has finished. And then I looked at some example instances out of this fleet which got terminated, and I found out the following. Carpenter has properly evicted all pods, and then it calls an AWS API, which is for virtual machines easy to terminate instances. And if it is successful, it immediately returns, but it will just tell you the current state is shutting down and the previous was running. And this customer was running really large instances, 192 CPUs, sometimes bare metal instances in our AWS cloud. And for those instances, they are not getting into the final state, which is terminated. So you have to run additional API calls, describe instances until the final state terminated is reached. From shutting down to terminate, it can take up to 15 minutes. And you can imagine what happened. So after 50 seconds, KCM marked those nodes as unreachable, kubelet not posting status anymore, and the monitoring tools of the customers, and I could verify this with two customers and two monitoring tools. One was an internal one, the other was just CubeStat metrics, which had the cube KSM metric for node status, and the nodes become unreachable. And this usually happens after these 50 seconds timer. And because for smaller instances, they reach the terminated state in less than 50 minutes. For smaller customers or smaller instances, we haven't seen this issue, but for larger instances, this happened to become very visible. And then node unreachable is at the end a state which is nothing bad, because the node is not under pressure, but just because kubelet is already teared down, because the underlying cloud node is going to be terminated. This status is reached, and this is kind of a false positive from the monitoring system of the customer, because at the end you have to correlate this to terminate instances calls from the EC2 API to be sure that it is not node pressure which is causing this, but just a node terminating. And that's why this was the initial reason where I created this issue requesting some kind of a fast path for Kubernetes node object deletion. Any questions so far? Did I
Ryan,
explain this properly?
Yeah, I have a question, John. When you say unreachable, does that mean, because I heard you say the kubelet's been torn down, is the node object exists and the kubelet is gone? Is that what you mean by unreachable?
Exactly. This is exactly the case. So because what Carpenter does, and I'm pretty sure Cluster Autoscaler does it in the same way. So if Carpenter, so let me elaborate a little bit more about this. Carpenter sees it can disrupt this node for whatever reason, be it emptiness or consolidate for whatever reason. So it will put a deletion timestamp on this Kubernetes node, and then it will call the cloud provider, in this case AWS API, to terminate the instance. The Kubernetes object is still there because there is a finalizer for Carpenter, and Carpenter will first remove the finalizer when the EC2 API replies with a terminated node status. Because for this kind of customer environment, it took 15 minutes to reach the terminated instance state. The Cadence node object was there for 15 minutes. And this causes the false positive alarms in the monitoring system. And after the 15 minutes, when the cloud provider returns terminated, then Carpenter removes the finalizer and the Cadence node object is finally deleted, but just after 15 minutes. Does this explain your question, Ryan?
Yes, I have more. I mean, I'm more clarifying questions. Why does it take so long? I didn't quite understand that. Like I think what your goal is, you want the node to be gone. You want the node object to be gone. I didn't quite understand why. Is it because of discovery? Like we don't understand like what the state the node is, or is it something else?
It's a cloud provider specific. So if you have smaller instances, these virtual instances are terminated much faster. I can't tell you the initial things which are going on, why it takes so long for the cloud provider instance to get terminated. It's just a fact that depending on the size of the instance, it could take just some seconds. So for smaller instance types, 16 vCPU instances probably they are gone from the cloud provider side into terminated much before 50 seconds, so KCM will not complain at all. But for these huge, or let's say for larger instances, the cloud provider takes so long to tear the nodes properly down and return terminated. So everything works fine. The EC2, so the cloud provider virtual machine API calls, they are just work fine. But Carpenter AWS provider waits until it gets terminated to be sure that the node is finally gone. This is the implementation specific of Carpenter using AWS as a cloud provider.
So would you say that like I'm trying to find where the gap is. Like, is that the gap that you're trying to do something with like this terminated state? Is it that we need some sort of discovery to understand and to tell our different controllers that they need to do work and to help speed this up? Because we can't, like, I think it's hard to say like how, because like you said, there's some downstream things that are going on for like removing things, right? So I'm trying to figure out like what though would be like the ask to help you speed up
Exactly.
the
So that's why
terminating. What's like the missing piece?
yeah, that's why I call this issue implement a fast path for Kubernetes node deletion. Because when we know the kubelet and the operating system is already properly shut down, for me, it doesn't make sense to wait 15 minutes just for the cloud provider instance to be fully terminated, because when we know kubelet is gone and the operating system is shut down, which just takes a couple of seconds, we could already safely delete the node object if we are sure all CSI objects are terminated, the CSI node is removed, and all other prerequisites. So having an additional signal like not only if you do graceful node shutdown, you at least have kubelet is shutting down. If you have another event like kubelet finished shutting down, then this could be an additional signal to do a kind of a fast pass deletion of the Kubernetes node object already. So this is at least my idea. Does this make sense?
I think I follow you. Yeah, I mean, I think what you're looking for, at least to me, it sounds like you want to know when you should start removing, like activating the downstream stuff to remove or deprovision this node. So the signal you're looking for or wanting to use here is that the kubelet's gone. So there's some additional questions to this, I guess, in my mind, which is like, I guess the way I'd describe this is like, you want to know when the node is drained, or like maybe more specifically, you want to know, actually, I think I just said it, you want to know when you can remove the node, right? You can do maintenance on it effectively, like, and so the node needs to be drained, and there can't be any sort of business critical workloads that are there. So yeah, I think so. It sounds like, yeah, you need a signal, but I guess the question is the kubelet being gone the right signal, or is there something else? I think that's sort of the thing we have to tease out.
Yeah, I think it's a little bit more which needs to be considered, because I mean, in cloud provider environments, you could still have some relationships to volumes or provision to the node by CSI node daemon set pods like EBS CSI for AWS, which first have to be properly dismounted. So this might be an additional signal that not only kubelet has shut down, but all volumes have been detached. So there is not a volume attachment object anymore, which points to this node. Otherwise, you get into other troubles. But at least it would be an additional signal that kubelet has properly shut down.
Does it make? Go ahead, Philip.
Yeah, I'm sorry, I came late. Can you please repeat what are the downsides in your scenarios?
I mean, a downside could be that you terminate the Kubernetes node object too early, and there are some dependencies on the Kubernetes node object which are not met, like volume attachments not properly deleted or things like that. But one can check this as well. So having a kind of a fast pass Kubernetes node deletion, and I feel probably other cloud providers have similar issues. I'm not sure. I can only speak for AWS, but I could imagine that Azure or Google Cloud have similar scenarios where it takes some minutes until a node, the underlying virtual machine, is terminated. And most probably they, Cluster Autoscaler or Carpenter for these other providers, just wait for the full termination as well, leading to the same issues.
So is it more that you are looking for the signal, or that you would prefer the node to be gone? So I suppose your main use case is the cloud providers, and you might not see the node again. But for example, when you are just restarting the node and like Kubernetes is down, and it might take some time to come back again. So would like having a signal be
I mean,
sufficient?
for this particular scenario, the node will never come back. So it's not a kind of a maintenance, because if you do terminate instances in AWS cloud, this node will not reappear. It has a unique instance ID. And if I say terminate instance, then it is removed from the cloud provider's API as well. And this is what I'm talking about. I'm not talking about doing a maintenance kind of thing. In my case, it's really, I delete the instance from the cloud provider API, but it takes so long for the cloud provider API to finally terminate it. Even though the operating system is already shut down after, let's say, a couple of seconds, or probably half a minute or think, depending of if you use graceful node shutdown or not.
I think maybe please shout if anyone disagrees. I think we should fold this into the use cases in specialized lifecycle management document. Does anyone disagree with that assessment? And then consider it as part of, as we are continuing to track, how are we actually dealing with the lifecycle of node maintenance? How do people feel about that?
Yeah, I was gonna say, I think this is gonna dovetail with what we've been talking about, and actually what I was gonna talk about next. I agree, we should have a use case for it there.
Yeah, Jens, are you good with writing out, because you're the expert on this, so are you okay with writing out a use case, and do you know the document I'm referring to here?
Cool. Yeah.
Absolutely, and thank you so much. All right, with that, and on a very related topic, let's now pop up to the agenda item from Ryan on specialized lifecycle management. Ryan, go for it.
Perfect. I think you gotta give me sharing permission. I'm getting
Yes, I
rejected right
probably
now.
do. Let me do that now. You are now a co-host.
Excellent. Okay, there it goes. All right, thank you. Okay, the link to the doc is in the meeting notes if you want to follow along there. Otherwise, I'll scroll through it here. So I'll just review, because we spoke about this last time. I'm kind of talking about it on Slack, and this has been circulating. But at a high level, for everyone, wrote out this document to collaborate with everybody on how we want to talk about these life cycle scenarios, these really complex life cycle scenarios that really span a bunch of different concepts that we've been talking about. And so that's the name specialized lifecycle management effectively is referring to the way that we can look at all these scenarios and how they're similar. And the way that they're similar is that a lot of these scenarios are involve an end user controlling and managing these different states that associated with a node. And these states are very custom, and they're really specific to the end user. And what's really important is that even though they are specific to the end user, we really want these these states to be shared and well known so that we can do signaling off of them. And that way we can actually build an ecosystem about different life cycle scenarios. And we think, at least that's the thesis, that that will help solve some of these really complex life cycle management problems that we're facing. And so as a goal we have here is that we're looking to define a bunch of node states and node maintenance states that represent these major phases of the node life cycle. So to review, based on last time, what we went through were the use cases that were here. Anyone can add their use cases, and so it would be great if people add more of these. And we went through these, and then I took them and put that into requirements, which I put down here. And I was hoping to review those today and get feedback on what's been written. Okay, so for requirements, I'll just go through these one at a time. This is based on my understanding from our discussion and what's been written. So tracking state is the first one that I have written. I'll highlight it here to see what I'm going through. So states, these should be, the idea is that we should have states that are observable and clearly defined by controllers to consume and manipulate data. Each state transition should be observable as an event. So I think to kind of expand on this, this is the idea that we want to have states. We want to have states that are going to help us with these specialized lifecycle scenarios, and we probably want to have them on the node, and we want to have these states expressed so that we can have all these building blocks around these states and really expand the ecosystem. So this requirement essentially just means that these things should be visible as much as and as far as possible, and we should be able to have lots of things reading from these different states. Okay, next, just stop me, please, if you got a question, just speak up or raise your hand. Second one, fellowship. So the solution must serve as a conduit between the core Kubernetes controllers and end user controllers. So I mentioned as an important part of this solution is that a lot of success, or to have success, I think our thesis is that the end user is going to define a lot of and control a lot of these different states. And it's really important that when these states we're moving between these states, that it is also parent to Kubernetes controllers that we're doing this. So we need well-defined states, and we want there to be we want this to be a relationship between a bunch of different controllers. And if you need an example of this, I think a good one we had from several weeks ago, someone from the schedulers team, I forget his name, was talking about a state where when we're returning from maintenance, where there's like almost we call it like an adding state or a provisioning state, essentially communicating that we're returning capacity by a node is going to soon be available. It's returning from maintenance. And that could be really useful for the scheduler to know and understand that something is returning, just like draining is saying that we're taking away capacity, and that also could be useful. So the idea is that these kinds of things should really form a fellowship, and we want to have these states defined so that controllers can work well together. And then third, I have, yes, go ahead, hand, I see from Philip.
Yeah. So I would like to expand on the like out of the core controllers and the core logic. So when you define states that's are, for example, fully managed by like external controllers, then like you will need to also define like what happens when these controllers are missing or when the states don't occur. So I mean, like we probably want to define some kind of states or API or controllers in the core. But like we should also focus like on like if we want to make it extensible, we also have to focus like what like the general like usability will be like for all the users.
Okay. So visibility, so this case would be, so I think where you're going with this is that, like if we have some sort of state and it's not It's not moving. It's not changing. We don't really understand what's happening. Like there are a lot of controllers who are waiting for that event to transition, but it's the problem is that there's no controller that's willingly or available to do the work to transition it. And so we want to know about that. There's no one who's sort of serving that event.
Yeah, so basically I think you either have to make it like either part of the core Kubernetes and then like it will be like available every time, or you might have like some optional states that some like clusters would have like components cooperating and using these states. And yeah, so that's like how I generally feel about it.
Okay.
I'm confused though, because if we define an API and controllers can be anywhere, right? I mean, it can be different codes that are using those APIs. So if we define a CRD, for example, we can implement it in multiple ways at just a CRD. Could you clarify your point, Philip?
Yeah, so like for example, like if we like we still don't know like what the implementation will be, but if you can expect maybe it might be like some condition on the node or some status on the node object, like if we take it simply for now. So and if we say that like for example we have a state for provisioning the node and this gets only triggered in some clusters by some components or like some then like in other clusters it will like this condition or status will not be available, so we need to make like clear expectations and like what the use cases are, or we might even define the API in a way that these conditions has to be present and something will block, but yeah, that's more complicated.
Okay.
Okay. I think so I left a comment here. I think that's a good one to have. I think a detail to have. So I'm gonna add that.
Yeah, I think
Okay.
one aspect
Continue.
here is not that some of the controllers missed like did something wrong or like missing. There is also a race condition aspect of it. Like if you have multiple controllers responsible for state transition, you may miss some of the transition because of race condition, and it will result in some inconsistent state. So that may be another consideration on implementation specific transitioning from state to state.
Yeah, but I mean, for example, if we are talking about state or conditions, condition should be implemented about one axis of observation. So there shouldn't be two controllers that observe the same thing at the same time. There should be one authority, that observes the things the right way. So if we are considering that things can be pluggable and controllers can observe their own way, but on a specific axis, then I don't see how this would be a problem. But the problem that Philip mentioned would be how these states would be, I would say, transitions. And then that would be to my opinion, that would be the implementation of the controller that deals with the whole maintenance. So depending on whether this, I would say, basic implementation becomes in tree, out of tree, that's for me a side concern. But the controller is the one responsible for transitioning, but it should not take inputs that are from two controllers that are dealing with the same kind of status. That doesn't make sense to me. I'm not sure if I'm clear though.
Philip has a hand.
Yeah, I agree. Like Sergey said, like we have to also think about the asynchronicity, and I think the main point is like how we will decide or how we will handle like who has the control over these things. So we will have to Like for example, when you look at like multiple schedulers, you say like which pod or which pod which scheduler takes. So I think like this has to be solved. And like, so for example, like when we were designing the eviction request API, like when you have like multiple actors, you have to make this clear, like who is managing what. And like
that I completely agree. I think we are saying the same thing.
yeah, and the rest what I was like talking about in the beginning is there might be some states that are not like possible to resolve by the like the control plane. And like we might try to like supplement for some of the states, like like create like controllers in the core that if there is no like extend like out of the tree controller that will take control, for example like the default scheduler. But for some states we might not have the default scheduler, so there might be a state that we might not infer from our own capacity, and this state is the one that might be optional, and you might have like zero or multiple controllers wanting to reconcile this state.
Okay, I added more notes. I think these are good questions, and I think they can make their way in here. I think we do need to figure these out. Okay, I think if there's no objection out, I think we can move on.
I think it's even
Maybe we'll
go
come
to,
back to that.
to this one. Yeah, the third
Mhm.
one is completely inside this conversation, in my opinion.
Yeah. Yeah, I think I think that makes sense. So I think it just needs some expansion. So end user controllers. So end users control how the state is manipulated and in what order. And then state control provide end users a building block for new APIs projects to solve these specialized lifecycle scenarios. So yeah, I think so. I think we just need some more detail. I think that's where this need could be expanded to precisely. I think you used the word authority. Like I think it's a good way to put it. It's like who's authoritative on that event. That's a good question. And then there's some other ones here that we need to answer too. Okay, I'm gonna move on. I think the next few are going to be related to, they're gonna sound like states. So declare drain. Controllers need a way to express that a node is undergoing drain. So declaring a node as draining is defined as the ongoing removal of assets, workloads, objects, etc. So this is intentionally vague because I think this one is, I don't, it's hard to define something like this. This is again a case where we're just saying that things are being removed. It's hard to say what. It's hard to really like say for certain exactly what will be removed. I think that needs to be up to the user. I think the only thing we can say is that something is being removed. And there should be a way to declare that. I think I saw a hand.
Yeah, sorry, it's me again. Is this binary? I mean, currently it is, but it is our intention to stay binary. Like, I declare a drain. Can a node have only one drain? That is, so can you see if it's draining? Okay, let's say that you have. I will give you two weird example. Let's say that someone wants to drain a node, and it's not draining daemon set current behavior, and then something wants to happen in the same maintenance where you want to do something in the daemon sets. If we were to think about cleaning the nodes of its pods and having certain interconnection points, those two ways of draining, or those two ways of doing something, of deleting those pods, would be different. So if you were to say, I want to declare a drain, what would drain mean here? So you said you are vague, but my question is it only, can you have only one drain?
I think you can have more than one. I think I think with this requirement, the only thing I want to get to communicate with this is that for anyone who's listening to these events, then they can see that this node is undergoing some sort of removal of objects. And that could mean, as you say, like many different drains. I don't even know, I can't even define what the drain is. I think that is completely up to whoever is doing the draining. So that could mean they could do many different drains of all different types and of all different shapes and sizes.
Yeah, so is that enough information? Oh, there was a hand raised, sorry.
Yeah, I have like the same topic or follow up. So yeah, I think you're totally right. Like there will be like different kinds of drains, and I would like to bring in the node maintenance API to this discussion, like as so far like what we have. So we modeled the node maintenance API a bit after the graceful node shutdown, and added like a couple of other features to this. So, and like as you said, you might have use cases like where you don't drain daemon sets, or like you drain iteratively, like the graceful node shutdown, or you might have like various drain scenarios. So like yeah, would be hard to define it as a boolean. But it might be possible like that we might even like have a reference like to the node maintenance or some like drain scenario that we have, or the cluster admin has put out, or somebody has created, and we go by this drain scenario, and then you could maybe cross-link and navigate and see like what is draining at what time and what are the expectations.
I'm trying to understand, like when you say by a Boolean, like is the well, I guess I don't see, I guess I'm not quite seeing, I'm not quite understanding, because the I think like all, like where I was going with this requirement is that we're just communicating what's happening. We don't really know at all or much at all about what is happening. So I don't know like how you want to look at that, if that's, so I just don't understand what you mean by Boolean here. What would be the big issue with
Oh,
saying it? Yeah.
it's not about an issue. It's to understand how to technically implement it. Sorry, I'm already going a bit further than what was asked here, but trying to understand if, for example, if we give an information about a node being drained, it basically does not give any information, in my opinion. It's, I mean, it gives one very vague opinion, information, sorry, and that information could be useful, but I guess we need to start somewhere. My point was, when drains are known to be non-easily described, so non-Boolean, defining you are draining or you are not draining might not be enough information. That was just my point. But if we need to
Okay.
start somewhere, it's better to know that it's draining than not having the information.
I see. Okay, I understand what you're saying by Boolean. Okay, I think so. This is where I was going with this, is that I think we need to start somewhere, and that a lot of like this is, for example, it's meant to be like a building block, and I think if you had something like this, then it would allow, I think at least the goal of this would be, it would allow you to then be more descriptive, and perhaps even in a CRD or something else, something that was very specific to what you were doing. But I think you have a hard time doing it without this piece. So that's why I was trying to go where I was going with this.
Yeah, makes sense. But I also appreciate Philip's opinion here when he mentioned like linking the two. It makes total sense. So gives your opinion and Philip's opinion, makes it like a sort of some kind of consensus during implementation. So sounds great. Thank you.
Yeah. Yeah, let me add a comment though, because I do want to make sure that it's clear that like that we can. This is meant to be like a building block. I think I saw another hand. I'll type while I don't know who it was.
It's Philip's.
Yeah,
Go ahead.
just that we can extend this point as like a like declaring a node drain scenario or something like that.
What's worst is I feel right now, and tell me if I'm wrong, Philip, but we want to get many things done, but if we tie them together, I'm afraid we'll not. It will not be an easy move. So building blocks sounds like the better approach, but we need to think about how we can phase them together. Don't you think?
Sorry, I'm missing your point.
Well, never mind. We'll see when we'll start implementing. Don't worry, we'll talk about that later.
Yeah, I mean, I think like this is one of the things like the drain or like declaring the drain or like this is one of the things we would like to implement in the core, I think. So like I'm not against like making it extensible and like having other components like add their own opinion to what like drain should look like. But in my opinion, if we want this in the core, like since like everybody would like to use this feature, I think, then then we can allow like ourselves to define it properly and plus like and add the extensibility later.
Yeah, but then it means that the work on specialized lifecycle management needs to depend on the work on the draining to be finished and completed.
I mean, not necessarily, but
Okay.
yeah, but it's a bit like tangled, yeah.
Yeah, these things are tied together. I don't know. We can think about it. I don't know if it is a dependency. I think, for example, like if you talk about draining, like the eviction work you're doing, that can exist independently. Like we could have an API that does an eviction request and can be totally independent. I think where I was trying to go with specialized lifecycle management is like trying to weave that eviction request to node maintenance to a bunch of these different things and what like the larger picture is and then understanding what we want to build from that. Go ahead, Philip. Saw your hand.
Yeah, I mean, yes, the same thing as I was like preaching before. Like we cannot, or it's hard to introduce like an API like without having any like core controllers, like to like without like introducing a conformance of the feature somehow. So like yeah, that's I think where I think we should probably start. But we net have to analyze all the like use cases and extensibility for that.
Yeah. Okay. I think we can continue. All right, we've got 15 minutes left for a quick time check. Okay, declare maintenance. Controllers need a way to express that a node is undergoing maintenance. Declaring an ongoing maintenance implies the node must be drained of business critical assets, workloads, and or objects. So what I'm doing is I'm tying together this declaration with the previous one as this would mean something that that you can take this when we're declaring this thing in maintenance, you can take it and do what you want with it because the assets that would impact your business have been removed. Any thoughts about this one? JP?
Just to make sure I understood. So when you say you declare a maintenance, the node is undergoing a maintenance. So it's, I mean, if I read the text, So you mean that you declare maintenance, it means that so you observe that the node is undergoing a maintenance. And so what you say here after that, declaring an ongoing maintenance implies the node must be drained. So it means that it's finished. Did I get that right?
Yes, that's correct. The node has been drained when you've declared a maintenance.
So, okay, this is a wording that I'm not used to. So it's a bit different in where I used to work. So here you mean that when it's under maintenance, it means that it's basically it's clean, it's ready to be maintained into whatever software or hardware thing that you need to do. That's what you mean.
Yes.
So you don't declare a maintenance as I want to make sure that that this node will eventually be under maintenance. It's you say this node is ready to be ongoing for repairs or something like that.
Yes.
Okay.
I have that one after. Like, so this would be like you say, it's ready for repairs.
Yeah, sorry if I'm using the wrong terms, right? English is not my native language. So that's okay, cool. I understand better. Thank you.
Okay. I'm happy to adjust these terms, by the way. Like, it's fine with me. Like, if you guys want to, if it's not clear, please, like, we can always change them. That's not a problem.
I
So
think
just let me know.
I think it's might be confusing in the first place, but it's basically it's maybe only me. So let's wait for other people to give their opinion, I guess.
Yeah, why don't you throw your comment in there, JP? Because I'd love to see a suggestion on this and a better way to communicate this. I think that would be great.
That's the tough part. It's English. It's what you're asking to a non-native to speak English.
Well, I mean, it would take a crack at it. I would think it would be great to see because I mean,
Yeah.
we don't know. I mean, who knows? Like, let's just see what you have in mind.
Thank you.
Okay, next one. So this was what you were just saying, JP. So this one be like ready for maintenance. We are declaring that. So I call it declare planned maintenance, which is sort of I use the word declaring a pending maintenance. So like we're intending to do it. We're intending to do maintenance and imply that the node may undergo maintenance at some point in the future. So I think to use the terms previously here, this node is not ready for maintenance and it's not draining. I guess it's not really doing anything. We're just saying that in the future, this capacity will likely be removed. We don't know how long, but it will likely be removed at some point.
Well, it gives enough information to know that maybe you should not schedule business critical workloads there if you have the
Absolutely.
opportunity.
Yeah. Yeah, that makes sense. Okay, any more comments on that one? I'll move on. How's the wording, JP? Does that one make sense? Like, I use pending. I don't know. I think that's like kind of what.
Yeah, I'll try to find better terms, but I doubt I will be better than you.
I want to hear some other terms on this because I think I think this is difficult to define. So I would definitely want to hear everyone's opinion on this. Go ahead, Philip.
Yeah, I think in the node maintenance cap we use also a bit different wording, and yeah, the terms are used in a bit differently as well. So yeah, you have to decide on like what's the best way to yeah. And yeah, and regarding the plant maintenance, I don't know if it makes sense. We saw like that's a lot of people are doing a simulation of the drain before it happens, or of the maintenance to basically pick the best node. So it might be like also a consideration, like if yeah, that's all.
Yeah, this would be so. I think we had the case I forget who it was, if it was Lucy. Yeah, we want to simulate the drain. So we take, it would think the idea would be like, we take the ones that are planned or pending and we do a simulation and then we decide which of the ones we want to work on or start draining.
Yeah, I'm just wondering if like maybe we can write that some like actors might declare simulation on the node.
I think I covered this a bit in the deferred maintenance use case that I put in, where I talked about visualization of what impact a maintenance has.
Yeah. Yeah, I think that's what we're thinking. I think that's what we're thinking with this requirement is that it was just targeting, like I was trying to target that is that you should be able to see like in the future what kind of capacity will be removed. We should be able to like plan it. That's kind of where I was going with plans. Is we should be able to see like, hey, this is going to be removed, this is going to be removed. And like JP said, maybe the scheduler shouldn't schedule things there. And then you could also do lots of things like you could simulate which ones we should target first based on the workloads that are there. So I think there's a few things this one can cover. A few use cases. Okay, we'll have to figure out the wording, the terms. I mean, I technically use two. I use like planned and then pending. Maybe this should just be declared pending maintenance, or we come up with another term. I think the node maintenance app has idle. I think that's similar.
Yeah, I think
So we
like
can
this, since
play around
this
with
is
that.
like a working document, like you can write like a multiple uh, of names and we can decide on the best one later.
Yeah. All right. Next one, declare maintenance ending. I talked about this earlier. This was it's actually the inverse of this one, which is the declare a drain. So drain, we're taking capacity away. This one is we're soon going to be bringing it back. And this one I talked about in the context of the scheduler, saying that, well, this capacity will soon be available. Maybe we should do something. So this is a way to declare that maintenance is ending soon and this node will be schedulable at some point in the future. Any thoughts about this one?
Yeah, I think we can also still, in all of these cases, also consider that as we saw in the beginning of this meeting, that the node can go away instead of becoming schedulable again.
Yep. Yeah, that's something to think about. JP, go ahead.
Ending is all the previous steps were about something that was ongoing. Is ending something that is ongoing? Is it really ending, or do we need something that declares the end of the maintenance? So is there an event that we need to observe, or is that a state on which we need to observe?
That's a good question. That when I took a stab at this, I'm thinking that it's ongoing because that was one of the use cases that was brought up from the scheduler representative as
Okay.
sort of because drain was sort of an ongoing operation, so ending would be an ongoing operation. I do think though there probably is an end state too, which is like we're done. I don't know how we express that. Maybe I probably need something in here for that to say that we've finished. So declare maintenance finished or something. I don't know how we want to do that. But maybe there is something for when we're concluding. Go ahead, feel it.
Yeah, I think like the end of the maintenance or end of the node is like a complicated topic, which we probably don't have time to solve today. And so because there like you can have like multiple outcomes of like the end of the maintenance. So even the node isn't there or it's coming up back again, and or you have to somehow solve like we have to also inject like the termination of the machine itself, like how it is happening, when it is happening, who triggered it, when, and like do we have some signals? So this is also consideration, like what the cloud providers are doing or would like to do. So yeah, this is like a pretty advanced topic, I think, and yeah, we'll need more thinking there.
Yeah, that's a good point. This could fit into that world. Yeah, like we're maintenance is ending, so we're deprovisioning hardware. I don't know. So it might not just be like, it might not just mean that its node is returning, right? It could be that it could be the node is actually going away. So maybe we need a way to express that somehow.
Yeah, I think like we need feedback from cloud providers here. Like this is something that will be important to them.
Do we have
Okay.
the context for that?
I mean, we talked a bit earlier in the meeting. The first issue we talked about was from John's. So we did get a little bit of context. I don't know, John's, if you're still here, did you have any opinion about this? Did you want to add?
Sorry, was on mute. Yeah, I mean it's exactly that. We removing capacity, so we remove CPU, we remove memory, and it's never returned back. And the fine nuance is that this process is it's a process. It's not just binary. It's not just the node is terminated, but it's this process in between. We issue the delete of the cloud provider instance, and it will take some time until it's finalized.
I feel like we need to get some more use cases on the ending states. So to be really good, I think that would help us in deciding what we want to do. I think, like, Johns, would you be able to add a use case in here for your issue in terms of what we'd like to see? And I think there's probably several more like we can get for end states. Like, what is it that we want? Like, what is the end to look like? This graceful node shutdown and how the cloud providers handle it. And I think there's probably several here. The scheduler had theirs for returning the node. So I think it would be good to have. Would you be able to do that? Maybe you can add it in here. You should have access to. You should have edit access.
Sure. I mean,
Okay.
give me please some days because I'm on vacation right now and on customer premise next week. But by the end of next week, I'm sure I can add this as a use case.
Great. That would help us a lot. Thank you.
Welcome.
Okay, so I think we have a lot to discuss with this one. This is, I think, where there is a lot of decision points here for ending. So we will need to spend more time on that. Okay, I think we're at time. I have 2 left, but we can cover it in the next one. These are also probably ones that will garner a lot of different discussion points too. So, and probably ones we need more use cases on as well. So I think we can end it there, and I think we can pick this up at the next available meeting. Is that good with everybody?
Yeah.
I'll take that as a yes.
Thanks. Yeah. Can I get a few seconds?
Yeah.
Yeah, I would just like to give a short update on the eviction request API cap. So I talked to Joel and he will give an API review soonish. And I also got review from Maciej from SIGAPS, and like we have a bit of a conversation there. So I summarized like what we discuss in our meetings a bit in one comment, like what we are experiencing, what problems we would like to solve. So please take a look, and if you agree or disagree with something, please let us know in the cap. Thanks.
I second that message. All right, folks, thank you so much for coming, and have a good morning, afternoon, or evening wherever you are.
Thank you.
Thank you.
Bye.
Feel better, Lucy. Bye.
Bye.